specific methods we're going to look at today are ArcGIS for AutoCAD, the different FDO data connections that you can make, including direct native geometry connections and why direct native geometry connections work and how they work. And then we're going to look at Civil 3D objects for GIS and some of the methods that we have used in the past to incorporate that data into an Esri geodatabase. So on November 15th, there was an announcement from Autodesk and Esri that they're partnering to advance infrastructure planning and design and the bidirectional workflows between Esri and Autodesk software. There is a commitment to GIS and BIM connecting the science of where to make anything. And that includes Esri ArcGIS for AutoCAD as a supported product and the Autodesk Map 3D platform as the basis for Civil 3D and products like InfraWorks to make those connections to GIS databases, including the Esri ArcGIS platform. So it's a commitment from Autodesk and Esri to continue what they've been doing. We also want to look at where GIS plays a role in engineering and architecture projects, because we do use and integrate GIS data in all of our CAD projects, whether we know it or not. Because everything has a georeference and a place, initially, during the initial project definition, we're looking at the location and creating base maps of data that are often stored in GIS systems. This contributes to the preliminary design for any of your CAD projects. As you move through the life cycle and get into detailed engineering design or detailed design and construction, then GIS starts playing less of a role as the project moves through its life cycle. So the order of operations for any kind of project, but specifically CAD GIS integration, always starts with the business requirements. We don't have the technology drive our business. So it's not technical Darwinism. It is us knowing our business and implementing standards that satisfy those business technical and requirements. And on that standards compatibility hierarchy, we start with our foundation where CAD and GIS data share a common projection, datum, and units of resolution. Once that's established, then we can move through the format, the naming conventions, the lines, the colors, and then ultimately start talking about how do we store data attributes about our graphic objects. The reason that we identify these areas of compatibility is to reduce risk when we transfer data between CAD and GIS systems. There are many things in a CAD system that don't make it to a GIS system. And there are many things common to GIS systems that the CAD operator will never use. But because it's all used in a life cycle for any project to manage our data, it's really important that we identify where those two data sets are compatible and ease that transition through knowing what the dependencies are and the commonalities are for each. And in identifying those, that is how you can create CAD features that are compatible with GIS objects. So we reduce risk by decreasing manual intervention, primarily. We automate these technical processes, ensure that they're compatible. This is the number one area where we incur error into our CAD and GIS data sets by manually transforming, manually moving, manually shifting, making decisions along the way that increase the potential for error and decrease efficiency in incorporating your CAD data into a GIS system and incorporating your GIS data into your CAD system at the beginning part of that process, where we saw that GIS plays a larger part in any of our CAD and our design projects. So making templates available and GIS data available in formats that are compatible, that are explained with resource packages, and develop applications that are standardized to ensure that these digital submittals satisfy a requirement for now and for the future. Many organizations are offering economic incentives for digital delivery, and there's an economic incentive as well for standardizing on the front end, so that we have less decisions to make as a CAD operator or designer, and that we know that what we're doing is going to be compatible with that GIS system when it's submitted. There are consortiums and standards committees that exist, and they're becoming more entrenched as we move forward, and there's lots of communication and documentation around those digital data standards across the country. So typically we see GIS playing roles in the beginning of projects, and then of course we end up making more detailed information through survey processes, field measurement processes, and amalgamating that information through a life cycle, ultimately back to our GIS system. We then use and tap into those GIS systems and the source data for 3D visualization and BIM modeling, and as well we centralize the files that were used to create all of that data so that we can always trace back and reference the legal documents that were used to create that rich database that we use for asset management. The City of Vancouver has CAD standards for digital submission. They have the CAD standards for contractors that were based on their original CAD standards. The City of Surrey has a digital plan submission process. And the City of Kamloops has developed engineering drawing submission requirements, and this is becoming more and more prolific with more and more organizations that we work with on a daily, weekly basis. So we have to ensure that we have a compatible data process for accuracy, ensuring that we know the difference between positional accuracy and relative accuracy. We have to know that it supports the business process. And really from the user perspective, because there's documentation and it's transparent, it makes sense. So when we bring data into GIS systems, we prefer not to redraw them. We prefer that it gets submitted in a format that is understood from the beginning to, say, be a grid-based format that we convert to a ground-based format, that we then submit in a grid or ground-based format, complete with the documentation to ensure that we have done due diligence along that process and ensure we know what the data sources are that came from GIS, that have been transformed, that are going back to GIS, and what the new features are that we've created and that the standards that we've used to create them are compatible with the end system. So there's also ways to limit or eliminate questions like renaming or changing attribution or limiting the number of times we reproject. We know that every time we reproject something, that is also potentially a source of error. And limiting translating from data formats. You would think that one day we have a vision where all of our design, all of our CAD, all of our GIS, all happens in the same BIM system. And that is definitely what we're working towards, but we know that we're not there yet. So we want to use these compatible data processes to decrease risk and increase efficiency. So what are these types of CAD GIS integration that we use? There are many types of CAD GIS integration. These are primarily the ones that we run into with our clients on a day-to-day basis. The first one is manual, and it is by far the most common still to this day, that many clients are manually opening CAD drawings, using GIS tools to manipulate and input that data into their GIS systems without necessarily always understanding, but often understanding the source, but still manually recreating or retyping or redoing digital data. The second one that we want to talk about is ArcGIS for AutoCAD, and really ArcGIS for AutoCAD in a practical sense, in a real design for construction, survey design and construction environment, and what that means as we use tools like ArcGIS for AutoCAD in that workflow. And then we want to talk about how we can use the FDO connections as well still, and what the advantages and disadvantages are to using FDO versus ArcGIS for AutoCAD, or when something like middleware like FME, say Software's Feature Manipulation Engine for doing GIS data translation, comes into play, and why we might use that over other things, and as well, direct programming. And we'll touch on direct programming as another way of using these open APIs to directly manipulate data, and there is a time and place for that as well. So in ArcGIS for AutoCAD, we have the potential to edit our GIS data from the data source and work with the SDE schema seamlessly through a map service. It used to be called the feature service, but it's the map service in ArcGIS that we can use to publish this data. And we can turn these CAD drawings into GIS data, and alternatively, we can turn this GIS data into CAD drawings. So we can provide the basis for electronic submittal up front. We can also use it to access the library of information that Esri has online. Up until now, we've used Bing Maps inside of Map 3D and Civil 3D, and then we've had to capture images and print them, but the Esri information is available and printable, all using the ArcGIS for AutoCAD tool. And we can then use all of that to streamline the data sharing between the CAD and GIS groups and improve communication through all phases. So I'm going to go ahead and, thank goodness that's enough PowerPoint for now. And I've created a template here that really is going to be driven by the GIS system. So I'm going to go ahead and add a map data service from an ArcGIS web feature service. And we can compare this to the same feature service that we would view through a web map. So as we publish that feature service, we can go ahead and add and connect to that service and bring the data in as CAD data into, in this case, Civil 3D 2018. So the plugin, completely compatible. ArcGIS version is 10.3.1, just so everybody wants to know that. In theory, compatibility, we've tested with 10.4. We haven't gone to 10.5 yet. It's actually 10.3. You can query data in using the entire extent of your service area, so the entire extent of the map service as published, which can be quite a bit of data. You can publish it in using the drawing extent, so the extent of your current drawing, wherever you're zoomed into, or you can select the corners of the window that you want to bring the data in with. We can add features for editing or for query only. And the reason why we might do it for query only, even if we had permissions to edit, would be if we were starting a CAD project. It's going to come in the same way, but it's going to bring it in as a read-only object. The next two options that we have are add and extract. So if we add data to the DWG, it's going to track the information based on the entity ID of the AutoCAD object that you're adding and track it against a GIS ID. So it's going to maintain and understand that relationship so that you could edit that data directly in the GIS database using a map service. If you extracted that data, it's only going to extract it as a DWG feature. So because this is a relatively small data set, I can go ahead and add that into my AutoCAD drawing. This feature is now in here as something that we can view directly the attributes inside of our GIS database. The nice thing about having access to the Esri GIS database directly is that we can take advantage of all of the geodatabase rules, including domains, that exist against any particular object. So I can go ahead and change the attribute of something inside of the GIS database. Now note that we're not checking this feature out right now. We're editing it locally inside of our AutoCAD system. And if somebody else is editing the same feature, the last person to get their edit in overrides the first person. So it's just an order of operation. It's not a traditional check-in, check-out like you would have done in the past. But now that I can update that data and as well even move, change, or add data, you can see that just by querying this information in, it's created a local feature class and an addition to my tool palette so that I can continue to add and edit data in this. So I've already changed an attribute. Now I'm going to go ahead and make sure that I use my snaps, because remember that we want this thing to be topologically valid. And use my attribution to, again, add data to my new service. Now if I synchronize that service, I'm just going to go and show you the web map again. Just take a look. And we'll zoom into this area here. And you can see that it still ends. So I'm going to go ahead and synchronize. So you see one feature to be updated and one new feature to be added to my Esri geodatabase through my ArcGIS system. So one feature was updated, one feature was added. I'm going to hit OK, and it's going to go out and re-query and bring everything, refresh everything from the server based on what we just updated. So if I hit OK, go back, refresh my web map, zoom into that area, you can see there's my new feature, and there's the attribution that I used to edit and add that. Now, if this was part of a GIS to CAD process, you know that we couldn't have done design without scaling the features to a ground-based feature from the grid-based feature that we queried it in as. If we were just doing GIS maintenance and we were adding data from a CAD file that had already been designed, we know that because we understand the data process, we already would have converted this design feature to a GIS feature by applying the scale factor for whatever survey control was used for this particular area. So anywhere in that process, we have to understand what it is that we're adding back to that GIS database and how we're adding it. So that's great for lines. We can bring in polygons, but what about things like blocks? So if we go back to our service, and it's just stored my username and password against this, and go to my water service, and instead bring in fire hydrants, and let's this time choose a select corner. And I'm still going to add the data for editing. We know that in GIS, it's points, lines, and polygons, and when we symbolize something, it really is a symbol. And you can see that it's used the point display defaults for AutoCAD to display these points as circles. So it's the DDP type, and it's changed it to a circle, and as we zoom in and out, it's using the relative percent of our screen in order to change those sizes as we go in and out. But if we look at one of these features and look at the GIS attributes associated with it, one of them is block name. So if you add a block name type as well as rotation and other properties such as block attributes into your GIS database and control them accordingly, then you can use that to drive out AutoCAD features from your GIS database, which is very different than what we're used to when we're using FDO data sources, and we'll contrast it when we get there. But when you use an FDO data source, you're not creating a true block necessarily. You're using a symbol of a block that then you can create a block out of, but here you're driving the block directly out of the database. So if I use this tool, field to block, it's going to go out, look at all of that information, come back, and wherever I had an attribute that had the DSTR in it, so you can see, we'll take a look at my attributes. And here's my DSTR that I have an identical block for in this drawing. Oops, that's drawing one. Huh. And there's my block. Okay, so here is my DSTR block, and that's why it placed those blocks where I wanted it to. So these features are very powerful. Look at my attributes, grab my block. So if I wanted to drive an object block attribute, I've tied a block attribute here to a field inside of our Esri GIS database. So now I'm populating this block attribute. If you wanted to look at that block, you can see that the ID block attribute in here matches an attribute inside of my GIS database, which is ID. So the corresponding names will populate the values now, not only of your block itself, but of the attributes through your GIS database. So you can now start to see how we can build a CAD file, manage the attributes, and interact very seamlessly with our GIS database. Locally, it creates things called local feature classes, and you can create your own feature classes, don't get me wrong, and you can point whatever layers you want and map them to a feature class inside of your Esri Geo database. But again, you know, here we are renaming and creating queries to manage the contents of those feature classes, whereas this just drives it out directly from the Esri database. And if you look at the layer that the feature class is on, then you can see that it creates them as a local feature class. So very neat, very impressive, and an easy way to ensure CAD compatibility, because we know what it's named in your GIS system. Now it's duplicating it as a layer inside of your AutoCAD system. And as a result, if you want to add anything or create anything and you put it on that layer, it's going to recognize that as an object to be updated inside of your ArcGIS system. So it manages it as equating a feature class based on properties, the easiest one is layer, to then update your Esri geodatabase with the information. Now there's a whole bunch of other, you can label data, you can create M-text through some of these other tools, and I'm not going to go through all of the tools today because we just don't have time, but you can then create labels and more complex labels and drive out information through your AutoCAD system. Oops. Anyways, my point here is that there are just a ton of different labels that you can create inside of your GIS system based on data from your GIS database. I don't know why that didn't work, but I'm not going to play around with that. So again, here we are driving that data out and interacting with that CAD data, and then we can use this host of services available through us through Esri as well. So you know how we're using Bing Maps all the time to drive out data and show background information? Well, here's a whole host of information that is available to us through an ArcGIS service or an Esri service. And because this is completely interactive and at no cost, we can bring this data in, it automatically comes in as a backdrop to our existing data, and if we go to any layout, that information is now available to us immediately. We don't have to resample, recapture information. Just let that catch up. If we want to remove anything at any point in time, we go into our GIS contents, right-click, and remove our service. Let's go in and grab one that might be a little more detailed. Being very slow, so that's fine. The point is that it does work interactively with our layout, and I'll go back in a minute to pull that up directly inside the layout and just plot it to a PDF, and it works just great. I've got a little internet hookup going here, so there we go. Okay, so now if I go to my layout, you can see how it gets more detailed as I zoom in. I can go to my layout, zoom into my particular area, and then if I were to want to plot this information, and I hit plot, I can continue, use my PDF, and hit my preview, you can see that that map plots seamlessly outside of my model space to my paper space, and I don't have to capture or do anything odd to do it. So that, in a nutshell, is the ArcGIS for AutoCAD tools and some of the ways that we can interact with that data inside of ArcGIS, inside of Civil 3D in this case. So we can also use the table-based views, and like I said, I'm not going to go through all of the exhaustive list of features that we have available to us, but note that it is definitely functional to drive CAD data out of your GIS system in multiple ways. Again, based on the business and technical processes and requirements that we have, that is what we'll use primarily to create the initial standards and templates that we need to use this information. So I do want to contrast that with using something like FDO. So here we've got a more traditional connection that we're probably used to, which is the 64-bit ArcGIS connection that we used for SDE. And you can see that in this case, I brought in the data using a service connection for SDE in this case to my map. And when I zoom in here, this is a more traditional way of symbolizing map data based on an FDO connection where we stylize it. And if we want to use something like symbology, then this is a particular line type, but we're stylizing it, and we're stylizing it based on the data. The feature labels are driven out of the data. And this is very different because these features, even though they're in AutoCAD, are not an AutoCAD feature, right? This is a map feature. So again, you know, as a map feature, it's not, it behaves a lot like an AutoCAD entity. It does support check-in, check-out, but it doesn't drive blocks out in the same way, say, or MTEX out in the same way that your ArcGIS for AutoCAD connector might do. So still supported, still works, and this particular FDO connector that we're using here is the ArcGIS FDO connector, and the note is that you have to have ArcGIS installed, so ArcMap installed on your system if you want to use that particular data connector. And that's why I did it on this other machine, is because ArcGIS and AutoCAD Map are both installed on this machine. So even through this interface as well, I could connect to this same data interactively using another FDO data connector, which doesn't require ArcGIS to be installed on your machine. So you notice that ArcGIS for AutoCAD uses its own data connection that doesn't exist in here. We just looked at this first add ArcGIS connection, which is very robust, but does require an ArcMap license on your system in order for you to run it. But it works great. And you can connect ArcGIS SDE using your normal credentials, provided that you have ArcGIS installed on your system. You could also connect to a file personal geodatabase, provided you have ArcMap installed on your system. But what you don't need a license for is what we were looking at before, ArcGIS for AutoCAD. No license is required for that because you're going against the map service, just as if you advertised it on a web map that we already did, and you could edit it through that web map as well. a little more robust tools inside of AutoCAD for editing. And then here is a direct connect to the same ArcGIS data inside of SQL Server. So this is yet a third way that we can connect to exactly the same data that we queried in through ArcGIS for AutoCAD. I'll just turn off that. Actually. So there's the direct native geometry connection to the DFPS main on top of the ArcGIS for AutoCAD connection. And this is still fully editable, but note that you don't have access to those domains or geoprocessing tools inside of ArcGIS. Inside of ArcGIS, you could go so far as to say that you have to insert a vertice where a line touched another line, for example. Or you can only use these domain codes inside of a drop-down or a date text box or a pick list. So again, advantages and disadvantages of using different data connections to the same data set. This is why I said at the beginning that technology doesn't drive what we're doing. It's based on the business and technical requirements, because we have all of these options available to us to connect to our data. It's now what matches our business and technical processes for now and for the future. So I'm going to shift gears now for a minute, and I'm going to introduce to you Jerry James. And he is going to talk a bit and show you how one of those other ways that we can get data into our Esri geodatabase. And specifically, this is an example of Civil 3D data and the different ways that you can use to get Civil 3D data into the GIS database.
Thanks, Richard. As Richard said, I'm going to walk you through the process, or at least introduce you to the process of getting native Civil 3D data into your GIS. As most of us know, Civil 3D has a number of different feature types that can sort of automate that process of collecting data. So there's surfaces and parcels and pipes and structures and that sort of thing. I'm going to focus on the pipes and structures. One of the key things about using pipes in Civil 3D is that you can collect attribute data while you're doing your design and feature creation work. So you can collect pipe slopes, you can collect information about the structures upstream and downstream, and that sort of thing, and that's all kept in a database within the drawing file itself. Now the question always is, well, how do we get that data from Civil 3D and into your GIS? So let's just first of all have a look at what kind of data I'm talking about here. So if you look at at your pipes here, you can see that that pipes, as you're collecting the feature data, you're collecting all this other data in this data table, very much like you would see in a database. There's all sorts of information. If I was to select one of these features, you can zoom in on that feature and see some information about the upstream structures, downstream structures, what the slopes are, you know, wall thickness, inside diameter, outside diameter, all that kind of thing. That sort of information, and some of it, maybe not all of it, is important to your GIS. So how do we get that information into our GIS? So one of the key ways that we sort of utilize and suggest is to use an application called Feature Manipulation Engine by Safe Software. A lot of municipalities and engineering groups have this software, but we're finding that a lot of groups are not sort of leveraging this, these tools to their maximum, and maybe don't even fully realize that they can actually utilize these tools to take that inherent Autodesk Civil 3D information and push it out into their GIS. So we're going to work with that same file that I was showing you here. There's a number of pipes and structures here that were created. I'd like to give a shout out to Matt Kohlberg, who actually put this together for me in very short order, so that I could show this today. This is based on the City of Vancouver's piping network. It was just some of their pipe data that was converted into that sort of pipe network information in Civil 3D. Now, we've created a web mapping interface, and I've actually put some of this information onto ArcGIS Online so that we can have a look at it today. You can see that these little yellow features here are, in fact, the structures I was talking about. And see the structures there, and you can see the pipes there. Now, this isn't all the information that was in that file, because I've actually put a filter in that in the FME workbench that only put out all the pipes and structures that were related to pipes that had a slope within a certain tolerance. I think I put it in there as less than 0.03 and greater than minus 0.02 or something like that. And those were the pipes that were actually output to that. So now what I want to do is I want to put the rest of them in. So the way that this works is you can actually isolate the file itself into two separate pieces. You've got the file part that has your structures and the file that has your pipe. Now, they're the same file, but you're just isolating out the attributes from each of those for a specific feature type, in this particular case, structures and pipes. And there's a number of different things that you can do. I've created a little attribute renamer, which allows me, because there are some limitations to field name lengths and that kind of thing when you're dealing with complex databases. You can rename your attributes. You can do, as Richard was talking about, we need to do grid to ground conversion. There's little transformers in there that you can use to do that type of conversion. In this particular case, we're doing a very simple scale, and you can do rotation. There's things you can do for rotation, and what we're doing is we're scaling around an origin. We also want to do geometry filters. In this particular case, I need to be able to take all of this stuff we've done these transformations here on both the structures and the pipes, because they're common transformations. But I also need to be able to isolate that out, because there's going to be transformations that we need to do that are isolated to the structures and then to the pipes themselves. So we can do different things like creating these parameter tests. Sorry, we're going to do geometry filters. So I'm isolating the lines, and all the lines are being drawn out into this stream, and then everything that doesn't match, which will be all your structures, go out into this stream. And there's some other things we can do here. I think I began to show you. There's this parameter test here, which is basically just looking at, now in this particular case, I'm looking at the opposite of what I filtered out before. So I should get all the rest of my features going into that web map. Now, to do these kinds of things, you can do other things. Like I did a buffer here to make sure that I grabbed all the points that I need. So I created a buffer. I then did a spatial filter, so that actually grabs all of the all those buffers that are attached or adjacent to the lines. Then I used all those buffers to grab the points, and then all those points are then exported out to here. I also created an attribute here which lets me understand those new features that are put in, and I have control over how I push that into the database. Same thing here. I created an attribute here to know which are the new features that I've created, so that I can isolate those, and if I have to look at those in the SQL Server environment or in the ArcMap environment, I can quickly and easily isolate those features that I've created. I've also created a little failover routine that writes out a report that lets me know all of the features that don't meet that specific. These are all the failed features from this parameter test, which has to do with the angle. So you can output these reports, as in this particular case I've used a CSV file, which will give you a table that you can then you can look at and see all the features that have failed at this particular parameter test. So these kinds of things are important when you're trying to move data between that Civil 3D environment where you have a standardized drawing environment, and you can move all that information across. You can push that into the SQL Server database, and you can actually do quality control checks, automate those quality control checks, which will lead into other types of conversations, like we've talked with a lot of our clients about that sort of digital submission frameworks. It also saves a lot of time. So sort of one of the standard ways of doing this in the past has been to export data out to SDF. Then you have to create that FDO connection with SDF in the Civil 3D environment and do bulk copy into shapefiles. And then those shapefiles can be brought in. Now that's a lot of steps and really hard to automate in that sort of Autodesk environment. So this will remove that requirement and allow people to automate this. Also, there are a number of ways to further automate this, so that you don't actually have to physically and manually run these work benches in your environment. You can actually put these on a Windows task scheduler event, and it will run these workbenches, so you can do these on a timed event. There is also FME server, which would allow you to actually drive these as on-demand events as well. Anyways, I'm going to quickly show you how this works. In the manual way, we just run the workbench. As you can see, there's a whole bunch of translation parameters that are set up, and these are all set up through the workbench. I won't go through that right now, but these allow you to control the input information that's required to do these transformations. One of the key ones here you can see is there's a scale factor and a scale location, so that that one grid to ground transformation that I mentioned allows you to have some control over that, and you can change that information depending on your requirements. So once you have all the information in there that you need, you just hit OK. It runs the workbench. You can visually see when things are happening. You can actually take if you understand your data, you can know when things are looking the way that they should. In this particular case, you can see how many features are being pushed out and how many are making their way through the workbench. So that should be done, because it says right down here, translation successful. So now if I go back to this web map here, and if I refresh it, now you can see that all the rest of the features have been brought in into the web map. So now you can work with those, and those features are now available to others through that ArcGIS for AutoCAD environment that Richard was talking about, as well as any ArcMap or anything like that, and any of these web mapping applications that you may have set up within that Esri environment.
Great, thanks, Jerry. And we did want to just say a word on APIs, and Jerry's developed a couple of APIs for us, which have been very useful.
Right. So the real power here is that when you're integrating with the Esri environment, is all of those feature web feature services that ArcGIS for Server can produce are built on top of a very well structured framework called the RESTful API, and so they're easy to access through a number of different development environments. So we've built a couple of different little JavaScript APIs that we can use for accessing that data in a number of different environments. So a lot of people are still utilizing the Autodesk infrastructure map server, for example, and in the past, you've been sort of isolated to using sort of standalone feature services. You couldn't access that power in behind the scenes that maybe the Esri environment might bring to the table. So now that with that RESTful service, though, you can actually access that. You can access feature services like I've added in the. This is a AIMS web mapping application. As you can see, I'm bringing in that same information that Richard was showing in ArcGIS Online. And that's basically just leveraging that RESTful endpoint that Esri produces when you create any kind of feature service in, you can see that I've got the pipe network here, all those features that were available in the ArcGIS Online environment are also available in the AIMS environment as well. And not only can you visualize that data, but you can actually also leverage the back-end information. So you can build these little utilities to look at information that is associated with each of these features. In this particular case, I've created a little hydrant point-and-click utility here. Not only can you actually access the information and the data in behind it, but you can also access the geoprocessing power that ArcGIS Online has. I just created a quick little buffer utility here that's actually buffering on a number of different let me try that again. Okay, sorry, that it never fails that when you want to show something it doesn't work. But anyways, you can actually access the ArcGIS geoprocessing utility from within any web mapping environment. That's what the point I was trying to get across here. So that's how we access ArcGIS for Server outside of that Esri environment.
Great, thanks, Jerry. So we're totally coming up on time. In fact, we've got 1 minute left. I see a lot of questions coming in, as I knew there would be. So what I want to ensure is that I know Danielle is logging everything, and we're going to answer all of your questions as well as we can. Likely offline because we've pretty much run out of time. But thank you very much for participating. And in the future, please reach out to SolidCAD for your technical support in this area. And again, we're going to get back to you with all of your questions. This session was recorded, and so we will be sending out the recording link as well to everybody on the mailing list. So again, thank you for your time. And we'll sign off. So again, look forward to our next webinar in the future. Thank you all for participating.